In this example, we are required to find the coefficient of b to power 6 in the expansion of 2b squared minus 1 over b to power 12. So the first step will be to write down the binomial expansion formula, which goes like this: a plus b to power n is equals to whatever comes first plus the general term, which is given by n choose r, a to power n minus r, b to power r plus whatever comes next. So we can identify a and b from what you're given in the question. Now, from what you're given in the question here, a is equal to 2b squared, b is equals to negative 1 over b, and n is equals to 12. So we just need to plug this into the general term to be able to find out how the general term looks like. So the general term is 12r 2b squared to power 12 minus r negative 1 over b to power r. Okay, so we know that we are trying to find here the coefficient of b to power 6, which means that the combined powers of b are 6. So basically we need the term in b to power 6 which means the combined powers of b are 6. Okay, so the combined powers of b are 6. So basically what you're going to do is to focus only on powers of b, and if we focus only on powers of b in the general term, we'll have b squared to the power of 12 minus r multiplied by 1 over b to the power of r. That should be equal to b to power 6, because what we want is the term in b to power 6, which means the combined powers of b are 6. So if you simplify that using laws of indices, you'll have b to power 24 minus 2r multiplied by b to power negative r will be equal to b to power 6. And if we just focus on powers of b, we are going to have 24 minus 2r minus r will be equal to 6, which means 24 minus 3r will be 6, and therefore 3r will be equal to 18, and r will be equal to 6. So given that r is 6, we can plug 6 into the general term. So the term in b to power 6 will be, so the term in b to power 6 will be 12 choose 6 2b squared 12 minus 6 multiplied by negative 1 over b to the power of 6. So we just need to simplify this guy here, and 12 choose 6 can be found from your calculator. So if you go onto your calculator and just plug in 12 choose 6, so the answer will be 924. So we'll have 924 multiplied by 2b squared to power 6 multiplied by negative 1 over b to power 6. If we simplify that, we'll get 924 multiplied by 64 multiplied by b to power 12 multiplied by 1 over b to power 6. So just, using laws of indices here, you can be able to simplify this to 59136 b to the power 6 as your term in b to the power 6. All right, and therefore to answer the question, because the question is asking, find the coefficient of b to the power 6. So the coefficient of b to the power 6 is 59,136. So you can say the coefficient of b to the power 6 is 59136. In this example, we are required to find the coefficient of r to the power 10 in the expansion of 4 plus 3r squared to the power 9. So the first step is to write down the binomial expansion formula or the binomial theorem. So a plus b to the power n will be whatever comes first plus the general term, which is n choose r, a to the power n minus r, b to the power r, plus whatever comes next. So here, by just inspection, we can see that a is equal to 4, b is equal to 3r squared, and of course n is equals to 9. Which means that the general term is, so the general term is 9 choose r, 4 to the power 9 minus r, and 3r squared to the power r. Now what we need is we need the term in r to the power 10. So we need the term in r to the power 10. That's what the question is asking, yeah? So, and you know, from here we can see that 3r squared to the power r will give us the term in r to the power n. So by inspection, we can see that r will be equal to 5, yeah? So just by looking at this guy here, we can see that if r is equal to 5, then the term that we'll end up with will be the term in r to the power 10. So basically, we can say here that by inspection, r is equal to 5. So if we plug in 5 in place of r, for the powers that is, so we shall end up with the term in r to the power 10. So our specific term from the general term will be, or we can say the term in r to the power 10, the term in r to the power 10 will be 9, 5, because r is 5, 4 to the power of 9 minus 5, and 3r squared to the power 5. And if we simplify that, we should be able to get what we want. So anyway, this will be equal to 9 choose 5. And by the way, 9 choose 5 can be calculated from our calculator. So 9 choose 5 will be equal to 126. So we have 126 multiplied by 4 to the power of 4 multiplied by 3r squared to the power 5, and this will be 126 multiplied by 256 multiplied by 243 r to the power 10, and that will be 7838208 to the power 10. So basically, to answer the question, the coefficient of r to the power 10 is 7838208. So the coefficient is 7838208.